Gut dysbiosis is the microbiological equivalent of a neighborhood going downhill fast. Under normal conditions, the gut is home to a vast, diverse, and remarkably stable community of microbes, an ecosystem that works collaboratively to extract nutrients, produce anti-inflammatory metabolites, and train the immune system to tolerate helpful microbes while fending off invaders. But when a high-fat diet, especially one rich in saturated fats and ultra-processed foods, enters the picture, this microbial harmony is rapidly and measurably disrupted. The first and most obvious casualty is microbial diversity. Numerous studies in both mice and humans have shown that high-fat diets reduce the overall variety of gut microbes. Beneficial bacteria from genera like Bifidobacterium, Lactobacillus, and Faecalibacterium, key players in maintaining anti-inflammatory balance, tend to decline. Meanwhile, pro-inflammatory species, including Bilophila wadsworthia, Enterobacteriaceae, and various Clostridia subtypes, often expand their territory. This shift creates a less resilient and more reactive microbial ecosystem, one that's quicker to provoke immune responses and slower to recover from stress. Beyond just who's living there, the function of the microbiota also changes. High-fat diets promote a metabolic profile in gut microbes that favors bile acid metabolism and lipopolysaccharide (LPS) production. Bile-tolerant microbes like Bilophila thrive in the presence of saturated fats because these fats increase the secretion of primary bile acids into the gut. This sounds harmless until you realize that the byproducts of bile metabolism in these microbes often have inflammatory properties. Worse still, LPS, a component of the outer membrane of gram-negative bacteria, can leak through the now compromised gut lining and enter the bloodstream, triggering systemic inflammation and contributing to insulin resistance, fatty liver disease, and even mood disorders. In parallel, there is a reduction in the microbial production of short-chain fatty acids, SCFAs, especially butyrate. SCFAs are anti-inflammatory compounds that nourish colonocytes, tighten junctions between intestinal cells, and support regulatory T-cell development. When SCFA-producing bacteria are depleted by a high-fat diet, the gut lining becomes weaker, more permeable, and less chemically protected, creating a perfect storm for chronic low-grade inflammation. This phenomenon, sometimes called metabolic endotoxemia, is a key step in the development of obesity-related diseases. There's also growing evidence that high-fat diets alter the spatial organization of microbes in the gut. Normally, commensals are kept at a safe distance from the gut lining by the mucus layer. But after sustained exposure to saturated fats, this mucus layer thins, and bacteria begin encroaching upon the epithelial surface. The immune system notices, and it doesn't like what it sees. Local immune cells start producing inflammatory cytokines like TNF-A and IL-6, triggering a feedback loop that reinforces dysbiosis and further weakens the barrier. At this point, the microbial composition and immune response are no longer reacting to the diet, they are shaping it, enforcing a new and pathogenic homeostasis. Worse still, this microbial shift is self-reinforcing. Once the dysbiotic immunity is established, it tends to resist recolonization by beneficial strains, even if the diet later improves. This is especially true when fiber intake remains low, or when metabolic inflammation suppresses the immune signals needed to support gut regeneration, like IL-22. So it's not just about eating a greasy burger and recovering with a kale salad. If dysbiosis sets in deeply enough, it may require concerted intervention, prebiotics, probiotics, dietary overhaul, and time to return to a healthier state. This all means that the gut microbiota doesn't just passively suffer under a high-fat diet, it actively participates in the damage. It shifts in identity, metabolism, and behavior to favor a more inflammatory, less metabolically supportive state. What begins as a dietary choice evolves into a microbial identity crisis, one with lasting repercussions for the immune system, metabolism, and even brain health. So while a high-fat diet may seem like a temporary indulgence, it can have long-term consequences on the tiny microbial civilization that keeps you alive and well. Treating your gut like a fast food trash doesn't just make your pants tighter, it can recalibrate your entire microbial infrastructure toward dysfunction. And no, your gut microbes are not going to forget what you did over the weekend.